Okay, let's start. So last class we finished order by, right? So we finished order by, and today we are going to talk about nesting queries. So before this slide, the 32, all the query we covered, like this one, this is one whole block, right? So this is the whole thing. So this whole thing is one block that contain select from where and the order by. Now we're going to talk about for one query can be embedded into another query. So you can see in this query, we have two components here. First component is select from where. So that's just like what we did in the past. But in the where class, we have this kind of comparison. So usually we do like a DN equal to something, right? Now we can say in, okay? And then I have another query here, and this query can produce a result. And this query result, if we read this, we can see I want to select the department number, and from the department where the D name equal to research. So this one going to produce a bag of department number, right? So this is the bag of numbers. And of course, because of this specific schema, department name equal to research and department name is unique. So this bag of number eventually going to have only one number, say department number 3 is research, then this bag contain only one number, but still it's a bag of numbers. So we can see the number in this bag. Okay, and so now you see two queries, they are together. So this particular query, this is the inner query or nested query embedded in the outer query here. Okay, so for nesting of queries, it allows us to solve more complicated problem. So for example, this particular query, we want to see the name, address of employee who work for the research department. And we know we can using one single block to answer the query, right? So I think we did this here, maybe. I have to... Okay, so this is the query, what we did at that time, exactly the same query, right? So we just need one single block, we'll be able to do it. And then now we can use nested query to handle similar situation. And usually we use nested query to handle more complicated problem. And the reason we use the same example here, let me find it first. The reason we use the same example here is try to show the logic instead of like a more complicated problem to analyze the problem itself. So if we, so I'm going to talk about more about this, but if we think about this in another way, okay, let's see how to construct this nesting queries. So basically I need to get the name, address of employee. So our output is coming from employee table. And of course, not all the employee, only they satisfy the following condition. So that's why the where clause, we take a look about the department number of each record. So this is the record of employee, record of employee, record of employee. We want to see the department number here. If this is in this bag of numbers, if yes, then this one qualify, can be in the output. So when we compare this D number in this bag, if this is no, then this one will not be in the output. So that's the way to think about how to run the nesting queries. So if we go a little bit further on the inner query, we can see this inner query can run by itself. We do not need the support from the outer query. So in other words, we just take this whole thing and run it, and you'll be able to run it without a problem, right? Not all the nesting query like this. We are going to see another one today that is, not necessarily correlated. So this is the one not correlated with the outer query, so can be run independently. And so when we have inner query, outer query, we have a certain restriction on the grammar. So you can see this is the one in the where clause, and we'll say department number in a bag. And when we do this one and this D number, they do not need to be exactly same name. So this is DNO, this is the number, that's fine. But they must be in the same domain and they are talking about the same thing semantically. So this DNO means department number, and this is department number. So semantically, they are the same, and of course, they are in the same domain. And when we have something in something, this one means if this one match anything inside, then the evaluation is true. In this particular example, since we only have one number written, so you don't see it, say if I have a bag of values, so just purely talk about, X in a bag of something, okay, and we'll see when it's true or not. So just using the DNO here, again, this particular one will not have more than one, but I'll give you an example more than one. So if I say DN 1, 2, 5, for example, like that. So if we want to evaluate DNO is in this bag of numbers or not, then we want to see, say, for example, this is 2 for the first record, then this is true because this particular one matching one of them. Okay, and so if this is 10, then this is false because 10 is not equal to 1, it's not equal to 2, it's not equal to 5. So this one is not in this bag. It does not match any of them. The logic of the in is means this one matching something here. We actually can see a more obvious example related to this in here. All right, so this is the one not inner query, not nesting, but this is a similar to show we can use something in something. Let's see this query. We want to get SSN of employee work on project number 1, 2, 3. So we can see P number in 1, 2, 3. So that's basically mean PNO equal to 1 or PNO equal to 2 or PNO equal to 3. So if one of them is true, means the matching one of them, then the given tuple evaluation is true and it can be in the output. All right. So at least we learn another way to filter data, right? So we can use the in to do that. Okay, let's go back. So this is a nesting for query to select certain tuples based on the where clause here. All right, so let's move on to this. So a more complicated comparison. Okay, so we did the in right first, and that's the easy one. A more complicated one is any and all. So this one is, I feel this is probably hardest one to explain in the whole SQL chapter. Luckily, once we learn aggregation functions, we'll learn that. And many people feel using aggregation function is more easier than this one. And most of the functionality using that can be replaced by using aggregation functions. So this is basically a good way to introduce nesting of queries. This is kind of restrictive, like in something, but we also can do things like what happens if it's greater than a bag of things, or less than a bag of numbers, or a bag of integers, or a bag of strings. How can we do that, right? So that's something we want to use any or all. And so from the wording, you'll be able to see when we compare a value, say compare 3 with a bag of values, or set of values, doesn't matter. When we do this, we need to give certain direction, right? So we know in means what. So now when we greater than, we want to say, oh, is this greater than every single one of them? That's actually all, right? So greater than first one and greater than second one, things like that. Or you want to do if 3 is greater than one of them, doesn't matter which one, greater than one of them, then that is true. So that's what the any or sum kick in. So sum, I feel probably is a better way. So they give you the same result, okay? Just either way, you can either one, you can use either one, but I feel sum probably is a better way. Just, you know, semantically feel like better than any. So like 3 is greater than sum means some of them, one of them, right? So any one of them, that's fine. Yeah, so that's basically any comment, any one of them rather than every single one, right? So we're going to use an example to show this more. And eventually when you learn aggregation function, you will see actually they are compared to the min or max, right? All of them means even the biggest one, right? And you know, things like that. So of course it depends on greater than or less than. So that's basic any and or. It's also you can alternatively using the maximum or minimum to handle things. Okay, so let me use an example. So this is the one I want to name an employee whose salary is greater than the salary of all employee department number 5. So let's first think about the logic first. So we have employee as the output, right? So we know eventually we're going to output the employee. And for each employee, I want to see if the following conditions satisfy or not. That is, I want to see the salary of an employee. So this is the salary of the first employee. I want to see the salary of the first employee is greater than, so I have greater than all the employee in department number 5. So in this query, we kind of need to know what is the salary of department number 5 employee, right? So once we know that, so department number 5, we have many employees, and each employee has a salary. We're able to get a bag of salaries, like 30K, 50K, you know, like 20K, things like that, right? So that's what the salary of department number 5. And I want to see if this salary is greater than all the salary here. So in this case, you can see if it's greater than all, means this one must be greater than the first one, must greater than the second one, and this one must greater than the third one. Of course, if you have, you know, like 5 employees, then you have 5 number. But this one, eventually, if it's all, if it's greater than, or that means need to be greater than the max, right? So it's a max in this case. So this one need to greater than every single one, all of them, the biggest one. So see, if the salary is 70K, then we can see this is greater than that. Then yes, this is in the output. Then we move on to the second employee, and we want to see, oh, this salary is 15K. And so we can see 15K is less than that, right? Then we don't even need to bother to check others because this one said all. So that's why this is not in. Okay. And the third one, I have 35K, for example. And so let's see 35. Okay, can run out of space. Okay, so let me see the 35K. It is greater than first one. Okay, that's good. So we're okay here, but this is not greater than that. We say all of them, right? So means this condition evaluation is false. Okay, so as a result, we're doing same things for the next one. And so now we can see some of them, like this one, will be in the output. So that's the logic here. So now let's see how to specify that in SQL. So this is a good one to, a good example to show how to use the subqueries, because we clearly can see this part can be done in one query, and the other part here can be done in another query. And we just need to make this comparison there in the where clause. Okay, so let's do a select from and where here. And so in this case, the from part, I'm going to do from employee here. And since I'm going to use a subquery, and I also know department number 5 employee also using employee table. So I'm going to use alias here. Okay, this particular example, the one I'm working right now, this is not required to use alias. You don't have to use it, still can answer correctly. But I strongly suggest, students, especially many of you, it's the first time you use SQL, strongly suggest you to use alias whenever you use subqueries. And it just like makes things easier and clear, tell you which is coming, for example, I use attributes, is that coming from which part. This particular query, since we don't have things correlated, so it's not significant, you use it or not to help you to, get a better score, or, help you to answer the question correctly. But when we move on further, you will see using alias can be quite helpful. Okay. So again, this is not required, but can be helpful. So we say employee as E1, and that's this portion, right? And eventually I need the name. So let me go ahead to just put last name, E1 last name, and E1 first name. And of course, if you want to put an initial, that's fine too. Okay, and we have that. And then I want to see the comparison, right? So I want to see salary. Okay, and greater than something. And now we are going to do another query to do this part. So how to do the department number 5 employee salary? That's another query. So this particular query, I'm going to retrieve the employee salary in department number 5. So we do a select from and where. So this from part also using the employee table. Okay, so this inner query have the employee table say as E2. So that's this portion, right? So this part. And I need to make sure E2's department number equal to 5, right? So we have department number equal to 5. And then I can restrict that's only coming from department number 5. And then we do a select. I'm going to take employee, this copy of the employee in the inner query. And I select the salary. So this one gave you a bag of salaries. Some of you probably feel, oh, how about we just do distinct salary? That's the same case, right? So instead of a bag, you get a set of salary. It will not change your query result because this is comparison compared to every single thing. So it is correct if you want to put distinct there, and also correct if you don't put distinct in this one. Okay, so this gave you a bag of salaries, and this one give you employee. Now we need to compare. Let me see, I made any mistake or anything. No, so now let me compare every single one, right? Remember when we evaluate the query, I want to compare this with this bag. And now let's compare this by all. So remember this one need to be more than all of them. So means every single one, right? So in this case, when I have two ways to compare, then or is the way to use. So I'm going to use or here. So the salary is greater than all the salary here. So inner query, inner query and the outer query, they using the same table, but they are different copy of the table. In this case, since they are actually two separate query, means this query can run by itself. It's not that significant. You have to put E1, E2 here. Means you don't put E1, E2, it still work. Okay. Okay, so that's for this or, and in this particular case, you can see since it's greater than all of them, that's actually greater than the max of that, right? Of course, if you do less than, that's different story. So that's for all, and if we have any, right? So as I said, any means any one of them. Doesn't matter which one, just one of them you can find satisfy the condition, then that's sufficient to get the tuple evaluation into true to output that. And so for this particular query, if I write differently without alias, it still work. So let me write this down quickly. I don't have space, so let me just hold on. Let me just okay. So let me just give you another one. Okay, so if I remove this at all, so I don't have this. Okay, so this the whole thing, the outer query, no alias, right? The inner query. Also, this is still correct. It's just because the outer query and inner query, they can be processed separately. Not all the query like this. This particular one, the inner query itself can run by itself without outer query. And you will see very soon when we have collated queries, you need to have a certain restriction. And so for me, I feel, because I use this, for SQL every day for so many years. So easily I'll be able to tell what to, where I have to use it, where I don't have it. And so to make things easier for students, I strongly suggest you always use it whenever you have inner query. So that way you don't need to think, oh, I might get into, mistake. Is that a mistake? I don't use it or not. It's just like if you understand how they process things, you can understand it better. Say this one can be processed separately, produce a result. And there's no ambiguity in the whole query evaluation, because this one, when we evaluate, we definitely know this is coming from here. And I'm going to talk about the scope of the inner and outer query very soon, and you have another time to better understanding the scope of those variables. Okay, all right, so I think any is fine, right? You don't need to, I don't need to give you an example. Actually, let me give you any here. So if I say salary is greater than any, right? And then I have the same bag, right? So let me just example, not this question anymore, 50K, 20K. So I have a bag of like this. So I say salary, and now I try to use any. Then if I give a salary, say my salary is 100K, then 100K is greater than any of them. And actually that's true, right? So this is, yes, this is true. And if I give another one, so I have a 10K there. And so 10K is greater than any of them. That's not true because 10K is less than, and less than. So this is a false. And if I give you another one, 35K, okay. So 35K is greater than 30K, right? So remember, this is any. So once one of them satisfy, then this is true. I don't care about the rest because this one said any. Okay. Okay, so now let's see. Exist the function. This is the one I'm going to introduce the correlated nested query. And I'm going to talk about the scope within this, and you'll be able to better understand the inner and outer query relationship. So this example try to show you a correlated query. That means the inner query need outer queries variables to run. So remember this one, this particular part, right? So we can just run this independently. We take this out, run it, give me a result, right? And now this particular example will not have the same situation. And we can use this exist function and to help us to know whether I have this inner query give me empty result or not. So is this situation exists or not? So let's see, we want to get the name of each employee who has a dependent with the same first name as the employee. So let's analyze the problem first. Okay, so let's see. My employee table will be in the output, right? I need the name of employee. And for each employee, I need to check a condition. So that's why you see I'm going to have where clause and to have this situation here. So the employee have a dependent. So each employee, we can see we have a dependent table related to employee table. I remember we have a foreign key there, right? And help us. That's the social security number. And so for the first employee, see, I have some dependent here. And first of all, need to have somebody, right? So we have a dependent. And not only have dependent, I have 3 dependents for the first one, but have to have the same first name. I remember when we talk about the schema, we assume that employee and the dependent have exactly the same last name. I know it's not true in real world. I would just make this assumption to make things easier. And so they have the same last name, but they their first name, like employee has a F name, right? And the dependent has a dependent name. That's the dependent's first name. And so now we want to see if they have the same first name or not. And in this query, say for example, this is Joe, the first employee here, and that's the dependent of Joe. I want to see, oh, the first dependent name is not Joe, so it's not okay. And the second is Joe, and last one doesn't matter, right? So once I have, so remember they must be a dependent of Joe firstly, right? They must be dependent. And then I want to compare first name. And now I see Joe and Joe. So as a result, this employee is in the output. And so now let me move on to the second one. And then I found out that this employee has no dependent. And then of course it's false, right? So this is not in the output. And the third one, see the third one has two dependents. And this one has some name different from this one. And this is also different name. So in this case, also there's a condition here. So this is also false. So that's the way we do this comparison. So up to this point, some of you may have a question. I know I haven't answered the query yet. You might have the question, should we always use nesting or query or not? And especially, if we have a simple case like this, should we use the nesting of query, or should we using the early example at the beginning of the SQL section, we use a single block to answer it. The answer here is there's no concrete yes, no on which one is better. So usually if you be able to use one single block to answer and the logic is clear, like this one, okay? So for this particular example, the better way to using one single block rather than nesting or query. But some of the query, like this one, better to use the nesting query, and some of the query is not possible using one single block. So it's all depends on the query, but it's not like promoting to say you're always using nesting query. If you be able to use a single block, clearly answer the question rather than so complicated, then go ahead to use that. Okay, so if you go back to this is an example to show, it's a good thing to use nesting or query because the logic is very clear using this way. Okay, then we just need to construct our query according to this logic here. So I need to write the outer query first. Okay, so the from part, I'm going to do employee as E here. Okay, and then I'm going to select the employee's first name and last name here. Okay, and then let me get rid of this. Okay, so now let me see the where condition here. So now I'm going to introduce a new one. So I'm going to use exists here. And this one want to see this following situation, okay, whatever we run here, exists or not. So in other words, we want to see this one empty or not. I want to see if this situation, like they have the same first name exists or not. Okay. And so how to do inner query? We know this is coming from the dependent table. So I'm going to do a select and from and where. And the from part, we identify this is coming from the dependent table. So let me see this as D here. And then I'm going to do a where clause here. And when we do this, one thing interesting is, you see, I say it's correlated. If you try to do the same way as what we did in the previous example, you will not be able to complete your query independently because this dependent, okay, when we think about dependent instance, I need to make sure this dependent and this employee, they are actually in a family, right? So they are related. So how can we do this? And we need to go back. I got too far. So I need to go back to my schema here. So now you can see, okay, so dependent has ESSN and reference to the SSN for employee. That's the one, SSN, ESSN, tell me employee and dependent, they are related. Okay, so that's a critical point to answer the query. So I need to make sure this dependence ESSN is equal to employees SSN. However, in this inner query, we do not have an employee table, right? So it is critical here, okay, very common mistake people made in the past is when they see, oh, I don't have this, then go ahead to put the employee here. That is wrong. So logically, this is where's the employee is here, right? That's the employee you want to compare. So you want to go back to the outer query to grab the outer query's social security number here. So you clearly can see this is a variable coming from the outer query. Okay, and we also need to make sure they have the same first name. And so this is the same logic, the dot dependent name. I need to run out of space. The dot dependent name is equals to this one come back to employee again, and that's in go to first name, right? Okay, so that's this side of the query. And now I almost done, but I have the select part here. So in this select part, basically this function, I want to see it is empty or not. So which tuple you, which column you select doesn't matter. So a lot of cases, maybe just every single thing of dependent. So for example, dependent has ESSN, dependent name, and I have to D and D, and what else? I have two more attributes, right? So I can do that. So that's basically I want to see, so this inner query give me a result correlated. I want to see whether this is empty or not. If this is not empty, this is empty, right? So you can put all the columns here. Another way to do this, a simplified way, is if you want to list all the columns, you can simply use a star here. So the star here, this is not a natural drawing. So the star notation in SQL, star means all attributes. Okay, so in this case, dependence, the star give you the same result as, I have to go back. So probably, so I have to go back. So this be equal to D dot ESSN, comma, D dot dependent name, comma, D dot sex, comma, D dot B date, comma, D dot relationship. So 5 attributes, actually not 4. Okay, so that's equal to that. So to make sure to understand, so I do select star from dependent. It's the same as you select this one, comma, this one, comma, this one, comma, this one, comma, that. So they give you the same result. So that's just because like a simplified way to say I need everything. Okay. So that the reason we use a star here is because which column doesn't matter. I want to see they are empty or not. Okay? So that's why I use a star here. And that's actually really common when you see SQL query, and we don't want to type everything, right? And this one actually gives me everything. Yeah. So I want to emphasize. Okay, so let's further see this example to show the scope of variables. And we all, you learn a lot of programming is sensitive to those things, right? So it's same thing in SQL. And so for query processor, anything query processor process, it must be no ambiguity. And we already know using alias is a good way to help the query processor to know which attributes are coming from where. So in this case, the inner query, so when you write an inner query can use outer query's variable. So you see here, right? So this is coming from there. So this is the whole thing coming from the employee in the outside. Inner query can use outer queries, but outer query cannot use inner query's variable. So when you do things like in a where clause or in a select, you cannot use dependent. That makes sense, right? Other programming language, same thing. So inner can use outer query, but not the opposite way. Another thing is if we have the same table name with the inner query and outer query. This is not the case, right? This particular example, we don't have it, but in the case we have, say, employee here again in the inner query. If we use alias, then the query processor processes it exactly according to your alias. With like if this is E2, for example, then you'll say E2 SSN or something. Then they will think this is coming from here rather coming from there because you use alias to restrict it. However, if you do not use alias, say, okay, not this example anymore. Let me just arbitrarily change this something else. So if you see, I have employee in the outer, I have employee in the inner, and no alias restriction. Okay? And if we have a case like this, then the query processor will handle everything according to the inner query. So when they see anything, they will take this first, consider this first before they even go outside to think of anything else. And this is always the case, like very confusing to whoever writes this, to whoever read this. So that's why, especially when you have both, like this case, like what I wrote down here, not to say whether you have grammar error or not when you try to run it, just simply using alias to restrict that. And in this particular query, it is wrong to put employee again here because you actually, the logical wise, you see you using the employee outside, not the one in here. Okay, so it's a bad habit. Just simply say, I need a table, I put in the from. You need to see this is from where, it's actually from this one. Okay, so this shouldn't be there in this particular query. So the previous example, you can see there's an employee here, there's an employee here. So that's okay, actually, even without, because when they process, the query processor has no ambiguity when they process this. They know I need to retrieve the file and then get all the salary. So again, go back to this, to make your own life easier, use alias when you have nested query. That's all, yeah. All right, so next class, we're going to move on to another one, and that's all.